Okay, we're in section 18 now, and this is the rational equations. All right, so we've learned a lot about rational expressions at this point. We've been dealing with rationals. What have we been doing with rationals? Reducing them, building them, adding them, multiplying them, dividing them. So we've done a lot. And now we're getting to equations. And someone says, is this new? It is, because equations with rational expressions in them, right? We haven't seen that except for really simple ones where those rationals were basically just simple fractions, where the denominators were numbers. Now we're going to start seeing problems where the denominators are not numbers. They are variable expressions, right? I got to emphasize to you that the method's going to be the same, right? The method's going to be the same. And we need to go through that method with you, and I'll certainly go to the whiteboard in a moment, but we'll go through this method over here. Then, of course, we'll take a very simple example. We'll go through this example over here. Our intent, though, after doing that is, to be able to solve a rational equation and then maybe do word problems that are related to rational expressions. We will do examples, though. Let me go to the whiteboard. And again, the lecture will be quite short, all right? The intent of the lecture, though, was just to introduce a topic, and then we go to examples where that introduction becomes more concrete by doing the examples. What do we really want you to know from that lecture material? It's kind of hammered across in the examples. So let me go to a new share, and I'm going to go to my whiteboard now. And just give me a moment to do so. All right, we are here. All right. So essential rules and procedures for solving equations. What kind of equation are we doing over here? We're doing what's called a rational expression. I'm sorry, rational equation. And now I got these rules to do it. The number one rule, simplify both sides. We have been doing that since day one. This often involves clearing fractions. By multiplying both sides of the equation by some non-zero factor. What's a non-zero factor we generally use? LCD. All right, number two. This has not changed since day number one. Get the variable term on one side by adding or subtracting the same variable expression to each side of the equation. All right. Now, granted, we have other methods. We have this, it's quadratic. We have methods for that as well. But let's not worry about that. What are we worried about? What we've done in the past, right? Yes, we've seen quadratics. We have techniques for that. Yes, we've seen linear problems. Now we're dealing with these rationals where the denominators are going to be variable expressions, all right? Get the constant on the other side by adding or subtracting the same constant each side of the equation. Divide both sides of the equation by the variable term numerical coefficient. We've been doing this for some time now. Check your solution. I can't say this enough. Please check. All right, let's take a look at an example. I'm going to pull it on the side, and I'll go through it with you. Okay. Okay, I'm looking at it, and I want to emphasize to you, this is an equation. It's conditionally true. I don't know what the condition is to make it truthful, though. If you look at these two things, though, here, they're not the same thing. Like this is not the same as this. They're not the same. But there's a condition being placed on the x that would make these two things equal. The method we have, and we'll go through it one step at a time. I want to get the LCD. Well, that couldn't be easier. I'm looking at it, and there's only two fractions, and they both have the same denominator. So what's the LCD? The LCD is x plus 2. Now what I'm going to do, I'm going to multiply both sides by the LCD. What's the LCD? X plus 2. I'm going to write this down for you. X plus 2 times 5x over x plus 2 equals, well, now I got to use the distributive property of multiplication. What do I mean by that? This thing here distributes across these two terms, one at a time. So I get 3 times x plus 2 plus 10 over x plus 2 times x plus 2. Well, what's nice about this, things do simplify. That's the whole point of it. This cancels and this cancels. And what are you left off with? Let's go through it. Well, on the left side, you left off with 1 times 5x, which is just 5x. On the right side, you left off with 3 times the quantity x plus 2, which is 3x plus 6, plus 10 times 1, which is 10. Now, by the way, I hope you realize this has become substantially easier for me to look at now. I can still go forward. I'm still on step number 1, simplification. What I'm going to do now is subtract 3x from both sides. And what do you get over there? 2x, 16. I get the variable on one side, the constant on the other. Now I'm going to do, divides all sides by 2. And what do you get? No, let's take a look. You get x equals 8. Now I realize what some people want to do is, oh, that's the answer. I'm done. The next question. Well, I got to go to that last step. And what's the last step? I want to see if it's true. So I want to take this over here again. I'm going to pull this back over here. And I want to see if it's true. I want to see if it's true. How do you do that? You take this thing here, you plug it into the original. This is the original. Let's see what we get. What's 5 times 8? 40. What do you get on bottom? 8 plus 2, which is 10. On the right side, you get 3 plus 10. What's 8 plus 2? 10. Okay, let's keep going through it. What's 40 divided by 10? 4. This is 3. What's 10 divided by 10? 1. It checks beautifully. I know this is the correct answer. All right. Now, granted, over here, I put the work down for you. And, what do we do? Well, let's summarize what we've done. We've certainly cleared the fraction by multiplying both sides by the LCD. There's only 2 fractions involved. We get this over here. When we did that, it was really simple to plow forward, right? The key, though, this sometimes here may not be the correct answer. That's why you must check. If it's not the correct answer, you are to cross it out. Okay, let's go to the next page. And I want to put on the next page, what you see over there is just me going through the check. That's all I've done over here. Okay, work problems. All right, this has something to do with rational equations. Something to do with it. All right, we're doing work problems now. We'll go through examples. Many algebra textbooks will introduce work problems as a way to apply concepts learned in solving rational equations. They're related to this over here. All right. There's a very simple formula which should be recognizable to you. I want to point out why that is. If you think about it past, we were given distance equals rate times time. But now they're generalizing work as being some concept. It could be a distance, by the way. Like, for example, if you're moving something, there could be a distance you move it over. That could be the work being performed. But now the work is more generalized, right? Something's being accomplished, all right? Not necessarily distance. It could be something else. And we'll certainly go through word problems, all right? So let's go through this and describe this to you. W here represents the work done. R represents the rate at which the work is being done. We have a rate at which it's done. Just like when we're driving a car, there's a rate at which the car is performing the work, which is covering a distance. And there's going to be time. Time is generally going to be in hours, could be days, could be minutes, could be seconds, but some unit of time that you're familiar with. Okay, these problems are not much different than the uniform motion problems that you've done in the past. They're not much different. Now, though, they're going to be written where they're going to look like a rational equation. They're going to look that way. They're going to look like a ratio of something, all right? And we'll go through that, all right? I got to be honest with you. It really does boil down to one thing, your ability to read. Reading is really, really the point of this thing over here. However, I can read things. Sometimes I don't understand what I'm reading. We want to get to that understanding. And what's the understanding going to be? It has something to do with this business over here. We will do examples in class. All right. Okay. So what are we going to do first? We'll solve rational equations, and then we'll solve word problems that are going to be work problems. They're going to be very consistently told stories, and we'll get to that one step at a time. Examples come next. Thank you.